So today we're going to talk about ellipses. We started yesterday talking about parabolas. And what we talked about yesterday was the topic that we're working on is conic sections. And the reason these are called conic sections, if you have a book, if you look at page 707 in your book, all these shapes come from slicing a cone with a plane. So if we take a slice out of a cone, depending on how we do it, we get a parabola, we get an ellipse, and we get a hyperbola. We can also get a circle, a line, and a point. But we're interested in the curves. So these all come from parts from cutting off a cone with a plane. So an ellipse, we're going to define an ellipse as the set of all points. And all of these we're talking about in a plane, so we're in a flat surface. The set of all points, the sum of whose distance from two points called the foci. We have two focuses. From two foci is constant. So this is how we define an ellipse. Let me get a picture and show you what we're talking about. Here's my first ellipse. And I want to go back. I'm going to do this. Capture. Don't want this. So here's my ellipse. And what this is telling us, let me make this a little smaller. So an ellipse is kind of an oval shape. And what our definition is telling us is we have one focus here, and we have one focus here. And if we look at a point on the ellipse, and I'll do my point in red, and we go from the ellipse to one focus, and from the ellipse to the other focus, we'll call this D1 and this D2. What the definition tells us is that D1 plus D2 is constant. So no matter where I am on the ellipse, if I add these two distances, I get a constant. Now with the parabola, the definition of the parabola was a little different. We said that the distance from the point to the focus and the distance from the point to the line called the directrix was equal. So this definition is a little different, but this definition gives us an ellipse. So an ellipse is an oval shape. We have two focuses. We call them foci. And we'll talk about these parts in just a second. So everybody good with this? This is our definition. So let me draw another picture and we'll label all of our pieces. Or I think we already have another picture here. So here's my ellipse. I want to move it just a little bit here. So the parts, we have two focuses, two foci. The point right here in the middle is called the center. So just like you think, that's the center. We have two foci. The segment that goes through each focus, the center, and these points at the end is called the major axis. So the major axis is the long axis of the ellipse. The points here at the end are called vertices. So this is one vertex. This is another vertex. The shorter axis of the ellipse is the minor axis. So the major axis is the big one, the minor axis is the small one. These points are called the co-vertices. So this is a co-vertex, and this point down here is a co-vertex. Yeah, Cedric. Right, so if our ellipse were, if instead of horizontal, if our ellipse were vertical, then that long vertical axis would be the major axis. So the major axis is always the long one. The minor axis is always the small one, no matter which direction it goes. So we have two foci, a major axis, a minor axis. The major and minor axis are perpendicular to each other. And the major axis, this is an important one to remember, the major axis goes through the center, the two foci, and the vertices. So all of these points, the vertex, the focus, the center, the other focus, and the other vertex, all are on the major axis. And what we're going to do when we write our equation is we're going to have numbers that tell us how far the focus is from the center, how far the vertex is from the center, and how far the minor axis, or how far the co-vertex is from the center. And that's how we're going to analyze our ellipses. But it's important to remember that the major axis goes through each focus, the center, and the vertex. Let me draw one more picture, and we'll put some numbers on here, or we'll put some letters on here labeling the lengths of certain sides. So let me go back here. I'm going to grab this. So for our next picture, you can put this on the same picture if you want. I'm just using different pictures so it doesn't get crowded here. The distance from the center to the focus. What's that? Is this distance is, we call that distance C. The distance from the center to the minor axis we call B. I'll use a small b here. And the length of the major axis from here to here is A. So the center to the focus equals C. The center to the vertex equals A. And the center to the co-vertex is B. And one important relationship with an ellipse is that A squared equals b squared plus c squared. And this is true for any ellipse. And the other thing that's important to remember on an ellipse is that the length of A from the center to the vertex, A is greater than B. So A is always the bigger number. The major axis, the length of the major axis is always bigger than the length of the minor axis. If they were the same, what kind of shape would we have? Circle, right. So if the major minor axis is the same, we have a circle. So this gives us the information we're going to use to analyze our ellipse, to write our equations. So just like yesterday when we wrote the standard equation of a parabola, we're going to write the standard equation of an ellipse. The standard equation of an ellipse looks a lot like the equation for a circle, and we can kind of treat them kind of the same way. So let's work on those. So the standard equation of an ellipse. And we'll do like we did with the parabolas yesterday. We'll talk about the horizontal major axis and a vertical major axis. So for this first one, we're going to say that we have a horizontal major axis. So this would be our ellipse like we drew before, where we have an oval kind of stretched in the x direction. So when we have a horizontal major axis, there are a couple of things that are always true. For an ellipse, A is always greater than B, and A squared equals B squared plus C squared. This is true for any ellipse. Our equation is x minus h squared over a squared plus y minus k squared over b squared equals 1. So what this is telling us, this gives us a lot of information. For our horizontal major axis, the other thing to remember is that the biggest number, this is kind of a little shortcut that I use, the biggest number is under the x part. The biggest number is under the x part. That will tell you have a horizontal major axis. A is bigger, so this is going to be a bigger number under the x part. For our equation, the center of this ellipse, it's just like the vertex for a parabola or the center of a circle. The center is the point HK. The major axis length of the entire major axis is 2a. If we look back here real quick, we said that the length from the center to the vertex is a. The entire major axis is 2a units long. The minor axis is 2b. The two foci, since our axis is horizontal, to get to each focus, we go from the center and we go over to the right C and we go over to the left C units. So our focus is going to be H plus or minus C K. So we're just moving to the right or the left from our center. The vertices are we go from the center and we go over a units to the right and a units to the left. We just move the distance a from the center to get to our vertices. So that's h plus or minus a. We're just moving to the right and left from our center, a units. The co-vertices. We go up and down from our center, since our axis is horizontal, to get to our co-vertices. So that's going to be h and k plus or minus b. So from our center, we go up and down along our minor axis. If our center is at 0, 0, our equation just turns into x over a squared plus x squared over a squared plus y squared over b squared equals 1. And let me grab another picture for this one. I just want to stick a little picture over here. Minus this one. Do that one. So there's our picture. And I'm going to draw in C goes from the center to the focus. So just like our picture before, but we have a horizontal major axis. So this is what our ellipse is going to look like. And our biggest number for a horizontal major axis goes under the x part. That's always how I remember it. Where's the biggest number? It's under the x. So I have a horizontal major axis. Questions on our equation? So our information about parabolas and about ellipses, it's really not difficult. There are just a lot of details. There are a lot of details to remember. So if you can keep the details straight, this stuff really is pretty easy. There are a lot of details. All right, let's look at a vertical major axis. What's that? Yeah, so this is the minor axis. Okay, so I think we got all that information in there. The minor axis length is 2b. Oh no, this gives us all the entire equation. That gives us everything we need to know. And okay, I think I see what you're asking. So we think about the parabola or the ellipse in terms of which direction the major axis is. That just helps us visualize, because the major axis tells us how it's stretched. And if we know which direction the major axis is, then we automatically know which direction the minor axis is. All right, so let's do the same thing for a vertical major axis. So if we have a vertical major axis, our equation just changes around a little bit. So always for ellipses, for these equations, a is greater than b, and a squared equals b squared plus c squared. And for a vertical major axis, the biggest number is under the y part. So the biggest number is going to be under the y part. So what we end up doing is just changing the place that the a goes in our equation. So y minus k squared over a squared. A is bigger, so it goes under the y for a vertical major axis. Plus x minus h squared over b squared equals 1. And notice in both my equations I have a 1 on one side, 1 by itself on one side. So we always want to write our ellipse with that 1 there. And everything else Everything else is the same. The center is at HK. The major axis length is 2a units long. The minor axis length is 2b units long. The foci, since our major axis is vertical, to get from the center to the foci, we have to go up and down. So to get to the center from the foci, we go h, and we do k plus or minus a. So or not a, sorry, c. To get to the focus, we go up or down c units from the center. To get to the vertices, we go up or down a units from the center. And to get to the co-vertices, we go left and right along our minor axis. So we're going to do h plus or minus b k. And if our center is at 0, 0, our equation just becomes y squared over a squared plus x squared over b squared equals 1. And our biggest number is under the y part. Questions on our equations? So again, the important things to remember, a is always bigger than b for an ellipse, the way we've written our equations. A squared equals b squared plus c squared. And where the biggest number is in the denominator tells us where our major axis is. The biggest number is under if it's under the x, our major axis is horizontal. If it's under the y, our major axis is vertical. And let me put a picture in here for a vertical major axis. I want this one. So there's our vertical major axis, and again, the distance from the center to the focus is c. So what we're going to do today, the problems, the homework, all have to do with looking at A, B, and C, where our axes are, finding the center, finding the focus, that kind of thing. So just looking at an ellipse in terms of these equations. Yeah, Cedric. Sure. All right, we good? So we're just going to look at a couple of examples of using these equations, how we look at these equations, how we're going to use them in problems. All right. So for our example, let's say we want to find the center the vertices and the foci of our ellipse 9x squared plus 4y squared equals 36. Now, a couple of things when we're doing these problems. One is once we get to a point where we can, strongly suggest that you draw a little sketch. It doesn't have to be accurate. It just helps you to visualize where the axes are, where your focus is, where your center is. It'll really help you solve these problems. Now, the first thing we see here is for our standard equation, we always have a 1 on the one side. We have a x squared plus something y squared equals 1. So we're going to divide everything by 36. So we get the 1 on the one side. So when I divide everything by 36, I get x squared over 4 plus y squared over 9 equals 1. So right away we know which direction is our major axis, vertical or horizontal. Where's the biggest number? Under the y. So our major axis is going to be vertical. So I'm going to draw a quick sketch. I know my ellipse. Now this isn't 0, 0. These are just my axes. So my ellipse is going to be stretched up in the y direction. And I know this isn't a beautiful ellipse. We just want to get an idea of what we look like, what we're looking at. So there's my center. We know we have a vertical major axis. From this equation, the biggest number is always a. So this number is a squared, and this number is b squared. So a equals 3, and b equals 2. And from this equation, where's my center? I don't have anything adding or subtracting the x. I don't have anything adding or subtracting the y. So we're going to be at 0, 0. So the center is 0, 0. So we found one thing that we're looking for. The vertices. To find the vertices for a vertical major axis, I'm going to go up and down a units from the center. So if I go up a units, this is going to be at 0, 3. And if I go down a units, it's going to be 0, negative 3. So my vertices are 0, and I can write this as plus or minus 3. So I'm going from 0, 0, I'm going to go up 3, and I'm going to go down 3, a units. And my foci, to find the, yes? A is 3, but it's under the y. So when the bigger number is under the y, we're going to have a vertical major axis. Okay? To find my foci, I need to find c. We don't have c from the equation. We have to find it. We know that a squared equals b squared plus c squared. So c squared equals a squared minus b squared. And we plug in to find c. So c squared equals 9 minus 4. So c squared equals 5. C equals plus or minus the square root of 5. And my foci are going to be on the major axis. So I'm going to go up and down square root of 5 units from the center. So the foci are going to be at 0 and plus or minus the square root of 5. Questions on how we did this? This little sketch can really help you solve these kinds of problems to figure out which direction we go from our center. All right, let's look at another example. We want to write the standard form for an ellipse, and for our ellipse we have the center at the origin. We have our center at the origin. We have a major axis. Our major axis is 10. And our foci are at plus or minus 3 and 0. So the first thing that I'm going to suggest that we do here is let's draw a quick sketch. So our center is at the origin. So here's my center. And the foci are at plus or minus 3, 0. So I'm going to go over 3 and up 0, and over to the left 3 and up 0. So what do we know right away? What direction is my major axis? Horizontal. So I have a horizontal major axis. I have a horizontal major axis. I know that right away. My major axis is length 10. So what is A? A is 5. We know that the major axis length is 2A. So 2A is 10. So A equals 5. A is always my biggest number. So where is it going to go, under the X or the Y? X, since my major axis is horizontal. So I can write the first part of my equation already. My center is at 0, 0. So I don't have to subtract anything from X. So I just get X squared over 25 plus, and we know it's going to be Y squared over something equals 1. So we need to figure out, to go under the Y, we need to figure out B. Well, what other piece of information do we have here? We have the focus is 3 units over from the center. So that's 3 units. So what is C? C is 3. We know that C equals 3. C is a distance from the center to the focus. So C equals 3, and we know that A squared equals B squared plus C squared. So B equals, or B squared equals A squared minus C squared, and that is 25 minus 9. So B squared equals 16. So B equals 4. So, and B squared goes under the Y. So put 16 there, and there's my equation. Questions on how we did that one? So again, not difficult, just lots of details to keep track of. All right, let's look at a last example, a little more complicated. We want to sketch the graph of 25x squared plus 9y squared minus 200x plus 36y plus 211 equals 0. So the problem will tell you that, usually the problems will tell you that it's an ellipse, what kind of graph you have. Our clue here that this is an ellipse is we have this 25 in front of the x squared and a 9 in front of the y squared. So we have different numbers in front of the x and y. So that tells us we're going to have an ellipse. In order to solve this problem, we have to complete the square twice. We have to complete the square for the x part, and we have to complete the square for the y part. And that's what's going to get us into our standard form. So when we have a problem like this, all we need to do is get the x parts together, get the y parts together, and get the number by itself on the other side. So I'm going to rewrite this as 25x squared minus 200x plus 9y squared plus 36y equals minus 211. So I just put the x parts together, the y parts together, and subtracted to get the 211 over on the right. Now when we complete the square, we're going to complete the square on the x part, and we're going to complete the square on the y part. And remember, when we complete the square, we want a 1 in front of the x. So looking at just this part, I'm going to factor out this 25. Because I want a 1 in front of my x squared. So I'm going to factor out the 25. I'm going to rewrite that as 25 times x squared minus 8x. So I just factored the 25 out of this first parentheses. I want to get this 9. I want a 1 in front of the y squared. So I'm going to factor out that 9. So now now I have the x squared by itself and the y squared by itself. I'm going to complete the square on this first parentheses and complete the square on this second parentheses. And we have to be very careful when we do this, because we have to remember this first parentheses is being multiplied by 25, the second parentheses being multiplied by 9. So when we complete the square on this first one, I'm going to say this is 25 x squared. We're going to add b over 2 squared. So b is negative 8 divided by 2 is 4. We square that, we get 16, so we get minus 8x. And I'm going to put this in red, plus 16. Plus 9, we complete the square on the y part. Y squared, b is 4. 4 divided by 2 is 2. And we add that squared. 2 squared is 4, plus 4y. I'm going to put this in blue. Plus 4. Now we've added some stuff to the right side. We have to add that to the, we added stuff to the left side. We have to add it to the right side to keep our equation, true. So this equals, oops, did it again. This equals minus 211. We have to add 25 times 16. This 25 is multiplying the 16 here, and we also have to add 9 times 4. For the second part. We have to add the 25 times the 16 and the 9 times 4 to the other side to keep everything in balance. So finally, and now this becomes a perfect square. This becomes a perfect square. I get 25. Go back to black here. 25 when this factors into a perfect square. This is x minus 4 squared plus 9 times y plus 2 squared equals, and we add all this together, and we get 225. We're almost done now. For our standard form of our ellipse, what do we need here on the right-hand side? We need a 1. So we're going to divide everything by 225. And I get x minus 4 squared over 9 plus y plus 2 squared over 25 equals 1. And now if we want it, the problem told us to sketch this graph. To sketch this graph, we would know that the center is at 4, 2. The major axis, vertical or horizontal? Major axis, the biggest numbers under the y. So the major axis is vertical. And so if I'm just going to sketch a graph really quick here. My center is at 4, negative 2. My major axis is vertical. A is 5. So it would go up 5 units from here. So negative 2 plus 5 is 3. So this would be at 4, 3. I would go down 5 units. So this would be at 4 minus 7. B is 3. So I would go left or right 3 units here. So this would be 1, negative 2. 4 minus 3 is 1. And this would be 7, negative 2. And my ellipse would look like that. Not a beautiful sketch, but you get the idea. Yeah, Cedric. Yes, that's a coincidence. That you couldn't generalize that into a rule. That just happened to work that way. All right. One other quick thing that you'll need for the homework. This is just, I just need to write down a formula. The eccentricity. The eccentricity, E is C over A. And we'll talk more about the eccentricity tomorrow.
So is this still from a quiz?
No.
So what are the chapters for the quiz?
The quiz is just the limits packet. Just the limits packet. All right, so we're on page 722. All right, there you go.
You have 17 through 13 on.
Oh, sorry, that should be 7, yes. Thank you.